Yeah, good morning to all. Welcome to CHEM JEE Academy. We are from CHEM JEE Academy. Now today we are going to discuss about the topic dipole moment. बेटा ये जो टॉपिक है वेरी वेरी इंपॉर्टेंट है, जरूर नीट में और जेई मेंस में आएगा. कंपल्सरीली विल गेट 4 मार्क्स फ्रॉम दिस टॉपिक. विल बी आस्क्ड वन क्वेश्चन, एक प्रश्न पूछा जाएगा. कंपल्सरी यू विल गेट वन क्वेश्चन इन नीट एंड आल्सो इन योर जेई मेंस. सो आज का टॉपिक है बेटा डाइपोल मोमेंट, which is in you will study this one in chemical bonding denoted by mu, right? So dipole moment denoted by mu. Now here, what is the meaning of dipole moment? You know the definition of this one beta. So dipole moment nothing but it is a product of, it is a product of, that is charge into the distance between the two atoms, distance between the charges. So it can be given as like this. So mu equal to charge into, that is the distance between the charges r. So here charge, the units will be coulombs, and also that distance will be in meters, coulomb meters, or otherwise we can also use that debye units. Debye units. So here, what is the meaning of the dipole moment? It is a product of the charges, the charge, and also the distance between the charges. So it is called dipole moment denoted by mu. Now this topic is very very important. You will surely get one question. Either they will ask the order, either they will ask the values, or they will ask which are the following, how many molecules are possessing the dipole moment in the given, out of say 6 or 7 they will ask how many will possess the dipole moment. Now, so for charge, that means to, that is to the, for the separation of charges, then there must be heteroatoms. There should be heteroatoms, right? Now we'll see the examples, very very important. We'll see different type of molecules, right? Like we'll see AB type molecule, like that we can say diatomic molecules, AB2. Otherwise we can say triatomic. Like that we can say, we can divide the molecules into AB3, that means tetraatomic, AB4 pentaatomic, AB5 hexaatomic, AB6 heptatomic, AB7 type. Okay, so like this. Now first we'll see the AB type. That means two different atoms. So all these HF and HCl, etc., HBr, HI, all they will possess dipole moment. That means mu is not equal to 0. The molecules which are possessing the dipole moment, in that molecules they will, in that dipole moment not equals to 0. That means they are polar. They are said to be polar. Okay. Now for AB type molecule, HF, HB, HCl, HBr, etc., all this mu not equals to 0. That's why we'll see some values like you see here HF, it is having 1.78 debye units here, like that HBr 0.7 and HI 0.38. Like, okay, the variation we'll discuss later. Now the one which are in the which molecules which mu equal to 0, they are said to be non-polar molecules. Non-polar molecules. Okay. Now here we see AB molecule, we have seen in this case is HF and HCl, the mu not equals to 0, they are polar. Now we'll go for the AB2 molecules, triatomic molecules. Now in the triatomic molecules, you see we will see different example like carbon dioxide, carbon disulfide, BeCl2, H2O, NO2, etc. But if you see, if you observe here these molecules are linear molecules, whereas these are angular molecules. In the case of linear molecules, already study करे. In linear में क्या होता, one side is can get cancelled by the other side force, so the net will be 0. So that's why in this case CO2, CS2, BeCl2, in the case of this these molecules, in the case of linear molecules AB2 type, mu equal to 0, and these are non-polar. Whereas angular Like you can take H2O, NO2. In that case, mu not equals to 0. Why? Because of their bent shape. Now, so this is, so here I'm underlying the polar molecules. So they will possess the dipole moment. Now AB3. Now in the AB3 type, you have two types will be there: trigonal planar and pyramidal shape. You can say AB3 type. You see here BF3, BCl3, AlCl3, etc. They are triangular planar. So here the net since they are planar, the net mu value is 0. Hence they are non-polar. Whereas in the case of pyramidal shape, they comes under AB3 only, but they are in pyramid shape. NH3, you can take a NF3, NCl3, PCl3, etc. They will possess a dipole moment. So here mu not equal to 0. Okay. Now next one is AB4 type. In the AB4 type, again we will find two types of molecule. Molecule will be AB4 type, but here it can be a tetrahedral or square planar. And also with the lone pairs, it may exhibit distorted structures like a seesaw structure. Now, in the case of tetrahedral and square planar, like you see here, CH4, CCl4, XCF4, in all these cases, mu is 0. Mu is 0. So dipole moment is 0. Hence they are non-polar. Now, whereas another example of SF4, here it is it doesn't comes under the tetrahedral or square planar. It is a seesaw shaped structure, so it will possess dipole moment. So it is polar molecule. Now AB5, again in AB5 also we'll find two types of molecules. One is a trigonal bipyramidal, another one is a square pyramidal. So in the trigonal bipyramidal, what happens is the equatorial and axial position there get cancelled, so the net effect will be 0. Hence PCl5, in the case of PCl5, mu equal to 0. Hence it is non-polar. Whereas in the case of BRF5, or you can say IF5, etc., in those molecules, the molecules are in square pyramid shape, so hence net there will be some dipole moment. So hence it comes at the net will be mu not equal to 0. Hence it is polar. Okay, is this clear better? Right. Very, very important. You will be surely you will get one question in Neet and also in your JEE mains. Very, very important topic. Just you take a screenshot of this board. You will get compulsory one question from this one. Okay. Now we'll discuss about this one later. Now sixth one, AB6 type. AB6 type molecules. Now here again AB6 nothing but here again we will find two types of structures. One is regular octahedral structure, another one is a distorted octahedral structure. In the case of regular octahedral structure also, what happens is that axial positions net will be 0, and also that equatorial square planar shape that will be net result will be 0. Hence mu equal to 0. So here it is non-polar. Whereas in the case of XCF6, because of the distorted octahedral structure, it will possess the dipole moment. Here in this case, mu not equal to 0. Hence, we can say polar molecule. Okay. Whereas in the case of ABF7, here it is, it will not possess any dipole moment. So here it is mu equal to 0. Now, so these are with respect to dipole moment of, in case of these are just now we have seen what I have underlined. All these molecules, they will possess the dipole moment. The remaining there in those cases mu equal to 0. You see here. In case of CO2, CS2, BeCl2, BF3, BCl3, AlCl3, CH4, CCl4, XCF4, PCl5, SF6. Okay, all these molecules in this case, all these molecules mu equal to 0. But what I underlined here, HF, HCl, H2, NO2, NH3, PCl3, SF4, BRF5, XCF6. Okay, in all these cases, the net mu not equal to 0. That means they will possess some dipole moment. Okay. Now, like this here, if you see here, so these are the examples of the molecule possessing dipole moment. Now, the factors affecting dipole moment. Now we are going to discuss about the factors affecting dipole moment. So dipole moment mainly depends on the two factors. So dipole moment depends on the directly, it is directly proportional to the, you see here some examples. Electronegativity, you see here HF, HCl, HBr, HI, you see here. HF is having 1.78, HCl is having 1.07, HBr is having 0.79, HI is having 0.38. So you see here, as the electronegativity increases, electronegativity of the atom increases, mu also increases. So it is dependent on the electronegativity of the atom. Now another factor is here the oxygen and like here nitrogen, it is possessing lone pairs. So it is also directly proportional to the lone pairs. So in on these two factors, dipole moment is directly proportional. So as the electronegativity of the atom increases, mu value also increases. As the number of lone pairs increases, mu value also increases. Okay. Now, whereas in case of SO3, mu equal to 0, whereas XeO3, mu not equal to 0, right? But even though some molecule like you see here, XeF2 and XeF4, even though they are possessing these lone pairs, the mu value is in these two molecules, mu is equal to 0. In these two cases, mu equal to 0. Okay, whereas in case of XeO3, mu not equal to 0. Okay, so mainly electronegativity and also on the lone pairs, number of lone pairs. Now we will see the dipole moment values of some compounds. Here if you see here, it is there in your NCERT book, very important, you have to go through this one. Just you check the values. H2O is having 1.85 dipole moment, HF is having 1.78, NH3 is having 1.47, HCl is having 1.07, CHCl3 is having 1.04, H2S is having 0.95, HBr is having 0.79, HI is having 0.38, NF3 is having 0.23. These values, they will ask the order. They will give four molecules and they will ask either in the ascending order or in the descending order. Okay, surely you will get one question. It is there in your NCERT. From the NCERT textbook only I have taken this one. You just go through this one. Okay. Now, next one, we will see some examples. So if the heteroatom is there, automatically there will be charge separation. So automatically there will be polarity. So what happens is a dipole moment will be there. Now among the molecules which are having dipole moment, the order, correct order. For example, if you take CH3Cl, CH2Cl2, CHCl3, CCl4. So among all these, the order will be CH3Cl greater than, the dipole moment of CH3Cl is greater than CH2Cl2, greater than CHCl3, greater than CCl4. Okay. Now among the halides, as I told you, as I told you here, as electronegativity increases, dipole moment also increases. Now with the methyl compound, if you see, actually it should be a fluorine, it should be there. First will be fluorine, but what happens is because of the high electronegativity and also smaller size, its bond length is shorter. So now what happens is its dipole moment is somewhat lesser than when compared to CH3Cl. So that's why here CH3Cl comes first, followed by CH3F, methyl chloride, followed by methyl fluoride, followed by methyl bromide, followed by last one is methyl iodide. So here this one is possessing high dipole moment. Okay. Now this because of here also the same reason. Actually after NH3 it should be NF3, but here at NCl3 next comes NF3 because of fluorine is high electronegative and also possessing because of smaller size, the bond length is smaller. So that's why CH3 is having a somewhat more dipole moment than compared to the CH3. Now, so this is the order of different halide with respect to alkyl, that is alkyl group. Okay. Now next one, if we compare the, just now we have seen these pyramid molecules, AB3 molecule, they will be possessing, which are having this pyramidal shape, they will be possessing dipole moment. Now if you compare the dipole moments of NH3, NCl3, NF3, the order of dipole moment is NH3 greater than NCl3 greater than NF3. Now if you see here, what happens is, in NH3, what happens is your lone pair will be there, like hydrogens. Because of nitrogen is electronegative, more electronegative than the hydrogen, what happens is the direction will be like this. So also this will be in this direction. So now what happens is, the all the dipole moment order, that is bond pair, and this direction is towards the lone pair. So there will be a net effect. Where in the case of NF3, what happens is, so your this lone pair like this. Now here in case of this fluorides, what happens is they will be in the opposite direction, because of your fluorine is more electronegative than nitrogen. So that's why its NH3 is having a more dipole moment than NF3. But why NCl3? Again the same reason, because of the high electronegativity of fluorine, followed by, because of a smaller size, so the bond length will be shorter. So automatically its values comes its value, its dipole moment is more than NF3. So the order is NH3 greater than NCl3 followed by NF3. Okay, very important beta. These are very important. You will be compulsorily asked one question on this. Okay, now we will see some more examples. For example, if I take say this molecules like this, you think that they will be get cancelled by the second one, but it is not true. Why? Because here you think that their dipole moment is 0, but this is not true. They are possessing dipole moment mu not equal to 0, because they are unsymmetrical in nature. That's why they are possessing dipole moment. So they will be possessing dipole moment. Okay, right. So from this video you will get surely one question, and very important. Now we will see in the case of organic molecules, you will be knowing that just now we have seen that benzene compounds. Now what happens is here, now there can be here say XX molecule is there like this. It can be at a meta position, it can be at para position, right? Now here the angle is 60 degrees, right? Here the angle is 60 degrees, here it is 120 degrees, here it is 180 degrees. So usually what happens is, as the bond angle increases, dipole moment decreases. So dipole moment is maximum with 60 degrees, that is at ortho position. But there is exception is there, we'll see. Now what happens is, suppose say here XX, that means two are of same kind. Two are of same kind means X can be here, either two can be electron withdrawing or can be electron donating. In this case what happens is, this ortho greater than meta greater than para. R though greater than, that means dipole moment of R though is greater than meta followed by para, where in which either the two should be, either they are of two should be are electron withdrawing, or they should be two are of electron donating type. Now in that case, we'll see one example with like this. Say methyl group is there. That means two are of same kind. So in that case, dipole moment order will be ortho followed by meta followed by para. Ortho followed by meta followed by para. So in this case, that is not important actually. We will calculate the net will value with theta value, that is under root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. That is not required here. So just you remember in the, if two are of same groups, that means two are of either electron donating or electron withdrawing. Like this we can say with the chlorine also will take ortho followed by meta followed by para. But now suppose you say one is X and Y. The other case we'll see, suppose here one is X and another one is say Y. That means two are of different groups. That means here say for example say here it is NO2 group is there. So electron donating, electron withdrawing. So suppose this is in case of X is electron donating, Y is electron withdrawing. Now NO2. Now here NO2. Now here the order is para is greater than meta, which is greater than this ortho. Okay, so the order will be para followed by meta, last comes ortho. Now in this case, we'll take the net value with under root of mu1 square plus mu2 square minus 2 mu1 mu2 cos theta. That is bond angle. Okay. Now in case of one electron withdrawing, one electron donating group, the value is para greater than meta greater than ortho. I hope you understand this one. So this is a very important topic, and surely you'll be getting one question from this dipole moment. Okay. All the best from CHEM JEE Academy. Okay. Thank you. We'll see in the next class. And for more information like this, you subscribe our channel CHEM JEE, especially for chemistry for JEE mains and also for advanced and also for Neet exams. Definitely you will see, you will notice we'll make the videos like this, which in within 20 minutes or within you can read the particular topic and you will be able to answer the question. Okay, so surely you'll be getting this one, and subscribe our CHEM JEE channel and do follow our channel. Thank you. All the best, better.